Welcome to this second presentation today. This is the, I'm backfilling for my colleague, Dirk Fuchsman, who could not be here today. So I use a different set of slides and you see a different title. So trying to surprise you, the title is still New Epoxy Floor Coatings with Unrivaled Fast Cure and Excellent Aesthetics. So this is actually the ad we're running. My name is Rob Rasing. I'm responsible for marketing within our product line, and this is actually the ad we're running on Prospector, which is a good summary of what you'll hear in my next 10 minutes talk. So we've developed a new curing agent that allows very fast cure speed with a return to service within 4 hours at 10 degrees. You still get excellent aesthetics. And in addition, you can apply up to about 500 grams per square meter. So it's quite a robust system. And that ties very well into what customers are looking for today in new product development. I am looking at the screen because my screen is not changing, so I'll look at the screen on the slides to see what's happening. So what is the ANQUAMINE 728 exactly? Well, in a nutshell, it is a new curing agent that is intended for use in coatings, primers, top coats. It's a waterborne system in water, in a polymer in water, so it has a relatively high molecular weight. Its viscosity data and solids data are very typical for waterborne epoxy systems. You talk about 10 pascals, 55 solids. In this case, what is special about this product is that you can cure it with solid epoxy resin dispersion, as well as with a standard diluted epoxy resin. So the AHEW, let's see how the pointer works. Well, the AHEW, the equivalent weight, is 250. If you use it with a solid epoxy resin dispersion, such as the AR555 or ANQUAMINE ANQUARES AR555, then we recommend the PHR 34. And if you use it with a diluted resin, you need a bit more material for obvious reasons, and you get a PHR of about 125. So our preference in primers, if you want to get that very fast cure speed, is to use it with a solid epoxy resin dispersion. What's displayed here is the ANQUARES AR555, which is a kind of a special product in that product line, and it's sort of displayed summarized over here. The conventional solid epoxy resin dispersions, they have the molecular weight distribution, such as displayed in the gray chart, more or less a single weight distribution, a single peak weight distribution. And those systems, they give you excellent fast cure speeds. So there's no difference. The difference is that they typically need a bit of coalescing solvent. They typically need a bit of solvent to work, especially at low temperature. The other thing is that this is a system designed for concrete coatings, and that means that the concrete is a bit temperamental. Dry concrete is very nice, but it hardly is ever there. So concrete's always a bit damp. And in order to get a good adhesion to damp concrete, you need a good film formation at low temperature. And that's exactly what the 555 does for you. It has a different molecular weight dispersion. We start from a different base. We start from a liquid epoxy resin base. And as a result, you see some of that liquid epoxy resin on the left-hand side, the lower molecular weight, still in there. And that helps for the coalescing. At the same time, you have a higher molecular weight component that gives you the fast track, that gives you the fast cure speed. So the combination of the two is ideal to actually help films cure at low temperature, form good film, and get a good adhesion on the total system. The point's not working, but the other thing you notice is that if you look at the EW 550 and the HEW 250, you would think there would be a 1:2 ratio to use this product with the 555 dispersion. However, you see that our PHR at 34 is clearly lower, and that 75% stoichiometry is something we found that is a very good performance point for delivering the right balance between the cure speed, between the hardness properties, etc. So that's our recommendation. Don't cure this at a 1:1 stoichiometry. As typical with solid epoxy resin dispersions, you need to actually back off on the curing agent. You need to under-cure them. and then you get the best results as displayed over here. So the product, as I mentioned, has two key features. So on the one hand, it delivers very fast cure speed. What's displayed over here is a comparison of the 728 with solid epoxy resin dispersion in comparison to a manic base with a liquid epoxy resin, which is a very conventional system nowadays to cure fast epoxy primers. And you see that in case of the ANQUAMINE 728, you get a cure speed of about 4 hours. With a manic base, you're talking about 10 to 12 hours at 10 degrees. Yeah, so at ambient you will have your 3 to 4 hours, but at 10 degrees you'll really have that longer period of time. And typically a workforce will tell you, job applicators will tell you that they will wait for a job at a job site for a system to cure for 3 to 4 hours, but not longer. If it's longer, they will come back next day. So the benefit of this 3 to 4 hours versus 10 hours is a massive benefit. You can actually apply the second coat on the same day. And that gives you a true advantage in using that system. You can apply, so back and service time is 18 hours. If you do a top coat on it and that cures within 12 hours, then the next day, Monday morning you apply, and Tuesday morning you can actually walk on the system. With the manic-based system, and typically if you want to have an emission compliance system, you talk about a bit slower curing systems in top coats. 2 to 3 days is not an unconventional return to service, and then you get this kind of comparison. So it makes quite a difference if you have your primer, a fast cure primer, versus a normal primer. The other thing displayed on the right hand side is in the ANQUAMINE 728, whether you apply 400 or 500 or 600 grams, you get a cure speed of this 3 to 4 hours. So it's a rather robust system to work with. It's giving you, the water is gone after 3-4 hours, and you can apply your next coat. The other part, the aesthetics element, is displayed over here. Aesthetics obviously is a very broad thing. So what we define with aesthetics is a combination of things. So it's the UV durability. It's also whether you can use a system with pigment paste and get a stable color over the pot life, which in epoxy again is a bit of a challenge. Typically epoxy systems, the amines are very effective in wetting the pigment paste, and then the color drifts over the pot life. So if you start in this room on that corner and you finish in the other corner and you connect the two surfaces, you've got, say, maybe an hour difference, and in that hour the color has drifted in color. And that's what you see displayed over here. The color has drifted in solvent-free epoxy, versus in this water-based system it doesn't, or it does actually to a much lower degree. And you see that you get much better aesthetics in that element as well. And finally, very well known that it's with solvent-free systems, you can only get high gloss systems. So typically, customers do apply another coat to reduce the gloss, to get a satin finish. And with a waterborne system, it's actually a quite easy thing to do to get your satin finish in the same second coat. I just wanted to show you very basic start formulations. We are clearly not formulators in our product line. So we do a proof of concept, and that's what you see over here. So you see the clear coat primer, which you can also convert into a pigmented system, in a pigmented primer, and then you basically apply the primer twice to get you a 3 to 4 hours on both the primer and the top coat. What we did in the experiments that you saw over here was a clear coat primer and a pigmented top coat. Details displayed over there. There's nothing unusual in this formulation. And you see here some basic data that part of it which I showed. You have a system of 3 to 4 hours cure. It's on 500 grams per square meter. A pot life of about 45 minutes. Good adhesion to damp concrete. So again, the thinking is not dry concrete, which is rather easy. It's the damp concrete which makes it quite challenging. The system will also cure to wet concrete, but I think that's less relevant. I mean, any applicator will tell you they will stay far away from the dew point in order not to get into trouble. And damp concrete is your best representative case for this case. In this case, emissions, we foresee that it has a very good potential to meet emission compliance on various methods. There's no plasticizers in this system, no solvents, and the way it's manufactured is actually very suitable for meeting those targets. We haven't, however, run these emissions, but that will be something that's just an add-on. The top coat, some basic data. It is less fast, but still in its category in liquid epoxy resin systems. This is one of the fastest waterborne systems you can get, also in the liquid range, comparable to incumbent waterborne systems. At low temperature, you still have about 12 hours. So combine that with the 4 hours on the primer, and you have a system with about, say, 16, 18 hours. So within your 24 hours, you're done. You have a 2-hour pot life in this case, and you see some aesthetics data there. UV. This is obviously not a PU system, so epoxy technically this is quite good, much better than solvent-free. But in terms of PU, this is obviously off the scale. So you have to put it in perspective. It's a pretty good UV in the epoxy range, and again high gloss, and the same thing for the low emissions that you can apply these very promising for low emission systems. And so that's actually my slide deck today. I would like to invite you for more information and a discussion in our booth. We're in hall 7A, 7A323, and it's a healthy walk, so come over and we'll give you a coffee and some more things to enjoy. Thank you for your attention.